Hello everyone, my name is Ihsan Khairar. I'm a math teacher. I've been a math teacher for about 15 years now, and I have taught in university as well as high school in the Malaysian national system and also IGCSE and now A-levels as well. So today I'm going to continue with discussing the solutions to Probability and Statistics 2 A-level paper 970963 May-June 2025. All right, so let's go directly to the question. It's a 7-mark question. All right, let's read through the questions first. The lengths of pencils made at a factory are normally distributed. The standard deviation of the lengths is sigma cm and the mean is supposed to be 10 cm. An inspector thinks that the mean is actually greater than 10 cm. He takes a random sample of 50 pencils produced at the factory and finds that the mean of these 50 lengths is 10.03 cm. He then carries out a hypothesis test. I still stumble upon that word. Hypothesis test. All right, question A. He finds that the value of the test statistics Z is 1.995, correct to 3 decimal places. Calculate the value of sigma. All right, so here what we want to be able to do is we want to find this standard deviation, okay, the value of the standard deviation for this normally distributed lengths of pencils made at a factory. Some of the assumptions we can make is that, since this is a factory, then there's a lot of pencils, right? There are a lot of pencils. Although we already have this information, normally distributed lengths. And here, this is the claim. The claim is that the mean is supposed to be 10 cm. This is not going to be important for this question. However, it's going to be important later. All right, so let's just go ahead and set up the calculation for the test statistics. We want to answer this question first. We want to find the value of sigma. We set the normal distribution for the sample mean. All right, we want to find the sample mean, the distribution of sample mean. Right, so the sample mean, let's call it x bar. It's normally distributed with the mean. So the mean of the sample mean should be 10 cm, right? This is the unbiased estimate of the sample mean. And then for the variance of the sample mean would be the variance of the original population, which is sigma squared, divided by the sample size, which is 50. So this is our distribution, and now I'm going to use it. All right, so let's go ahead and calculate the test statistic, and we will set it to 1.995. All right, it should be the value of the sample mean from the sample, right, subtracted with the mean that is in the claim, right, and then divide by the standard deviation. So we'll have to square root this variance, so we'll end up with sigma divided by square root 50. And we'll set this to be equal to 1.995. And if you notice, we have an equation with only one unknown, and that means we can then solve this. So just simplify and rearrange, and in the end, you will get our sigma to be this. And this is the point where then we can use our calculator. And when we press it, we get 0.10633 and some more. And so correct to 3 decimal places, it is actually mentioned in the question, so this answer will not be accepted. So you will have to use 0.106 instead. So this is our sigma, correct to 3 decimal places, and if you got this, you did a good job. All right, so after we did this good job, let's move on to the next question. All right, so carry out the hypothesis test at the 2.5 significance level. All right, so to do a hypothesis test, we have to start with the null hypothesis and the alternative hypothesis. And we know that this is going to be a one-tail test. The reason is because we look at the objective here. He thinks that the mean is actually greater than 10. So we start with the claim for the null hypothesis. So sigma, sorry, not sigma, this is mu. Mu is equal to 10. Okay, and the alternative hypothesis, this is what we want to test for. We want to test if it has increased, right? Greater than 10. So we set our mu larger than 10. So this is our alternative hypothesis. So this is going to be a one-tail test. So our alpha value is 0.025, and since this is a one-tail test, we need to only refer we can refer directly to 0.975 in our MF19. So for the probability value 0.975, we find that the Z critical value is 1.960. This is from MF19. All right, so our Z critical value is 1.96. Now for a one-tail test where we want to find out if our mean has increased, right? We want to check if our test statistics is larger than our Z critical value. If the test statistic is larger than the Z critical value, that means we can reject the null hypothesis, or we have enough evidence to reject the null hypothesis. So we look at our test statistic Z, right? We get it to be 1.995, and this is indeed larger than 1.96. So this means that we can reject the null hypothesis and accept the alternative hypothesis. So we can conclude that there is enough evidence to suggest that the mean length of pencils at the factory is greater than 10 cm. Now how to write this conclusion? Simple enough. If you do reject the null hypothesis, then just say there is enough evidence to suggest that, and then we are checking that the mean is greater than 10 cm. So we'll just use the same actual phrasing just to be safe, right? So we'll say there is enough evidence to suggest that the mean length of pencil is at the factory is greater than 10 cm. All right, so we'll just use the wording in the question just to be safe. It's actually a safer thing to do in terms of writing down the conclusion to our hypothesis test. All right, and if you got that you did a good job. All right, so let's move on to the next part of this question, and that is part B. Explain whether it was necessary to use the central limit theorem in carrying out the test. Now, you have to think about what the central limit theorem is for, and it is for us. Central limit theorem just says that if you have a large enough sample, right? Even if we don't know the probability distribution of the original population, if you take enough sample size, if the sample size is large enough, then the distribution of the sample mean will approach a normal distribution. So that is what the central limit theorem is for. It is usually used when the population distribution is either unknown or known to be not normally distributed. Now, do we really need to invoke this? Do we really need to use central limit theorem in carrying out this test? Actually, no. Because why? Our original population distribution is already normally distributed. So even though we do have a large enough sample, it is not necessary to use the central limit theorem, because when we randomly select from a normally distributed population, our sample will also be normally distributed. So we can conclude that it is not necessary to use the central limit theorem because the lengths of the pencil made at the factory are already normally distributed, right? And that's one mark, right? So now sometimes students who don't understand the concept will just say, hey, this is a 50-50 question where you answer yes or no, and if you're lucky, you just say no, not necessary, and you get that one mark. Actually no, because this question says explain. If it says state whether it's necessary to use the central limit theorem, and then you say no, and that's good enough, right? You'll get that one mark. But it does here say explain, and so you will need to actually explain why your answer was not necessary, right? Okay, so make sure that you look for the keyword. If it says explain, that means some more stuff is needed rather than just a yes or no answer. So in this case, you do need to explain why that the central limit theorem is not used. So, and that reason is because the lengths of the pencil made at the factory are already normally distributed. And so if you answer this way, you have done a good job.